Hello बच्चों, welcome to channel Easy Physics. Today we will discuss kinetic energy concept and potential energy concept. As we know, the kinetic energy formula is half mv square. We will drive it how it comes. Let the object mass is m, moving with velocity v, and opposite force F is applied to stop it, and it stop at distance x distance. Initial velocity v and stop become 0 at distance x, applying force F. So work to stop this moving object will be F multiplied by x. F is the acceleration of that body in the negative direction, mass into x distance. So work will be half, the work will be m, and acceleration is equal to, as we know, final velocity minus initial velocity is equal to ax from the motion in one plane equation. V naught is equal to 0, so v square is equal to 2ax. A will be v square upon 2x. So putting a as v square upon 2x, the work done will be x will cut x, there will be mv square upon half, so half mv square work. The total work done to stop the moving particle is half mv square. So initial energy of the moving particle will be also half mv square, so we have to do work half mv square to stop. So kinetic energy of the particle we can say is half mv square. Simple. Now we will drive potential energy concept on earth. Let the mass of the earth is me, and the distance r, and moving distance, small distance dr, and the force by the gravity is F. So work done, small work done will be dw is equal to force into distance, this is dr. Integration on both sides. Work done from position 1 to 2, work is 1 w12 is equal to constant will come outside gmm dr. We can write down r2 as r e power minus 2, so minus 2 plus 1 on integration divided by the same minus 2 plus 1. This will total work done will be minus gmm, minus this minus will come outside gmm upon 1 upon r square minus r1. This is a work done from position r1 to r2. This is a work done to move that body. Okay. Now we will calculate the work done from position r to infinity. So this is the r, this is the distance. So the potential energy at that point is PER. Potential energy at infinity, we will suppose this is to be 0. At infinite distance, the potential energy of that is 0. So r distance infinity is infinity, and so the work done from position r to infinity, putting in this minus gmm, r2 is our infinity, 1 upon infinity, 1 upon and the initial distance is r, that is r. The work done from moving the position from position r to infinity is gm, mass of earth, small mass of the body, upon r. Now we will calculate the potential energy at distance r on earth. As we know, potential energy at distance r is PER, and we move the position this object to infinity. So the potential energy at distance r plus work done to move that body into the infinity will be potential energy at infinity. Simple. So that, but potential energy at infinity is 0. So potential energy at r distance plus work done from r to infinity will be 0. And potential energy at distance r is minus will be minus work done. So potential energy at r will be minus, and work done from r to infinity we have calculated. This is work done. This is gmm. This is gmm. This is a work done from moving object from r to infinity, gmm upon r. So putting this in this, so potential energy at distance r from center of earth will be minus gmm r, and potential energy at infinity, if we suppose is 0, so the potential energy at distance r from center of mass will be minus gmm on r. Now we will drive the escape velocity. Escape velocity is the minimum velocity of on earth's surface, so that it will never come back to the earth. So that r is the distance, or re is the distance or radius of the earth, v is the velocity, minimum velocity. This is the escape velocity. So using the concept of energy, the potential energy at that point plus kinetic energy is equal to kinetic energy and potential energy at infinity. Let the potential energy at radius r is, as we from the equation, this is the minus gm em r. This is the potential energy r, and the kinetic energy at this is a simple half mv escape velocity square, half m square, and the potential energy at infinity, as we know, is 0, and kinetic energy at infinity, because we are supposing the minimum velocity, so that at infinity the velocity of the object just stops. So the kinetic energy at that point is also the 0, because we are taking the minimum velocity, so that it stops just at infinity. So totaling that, this plus this will be equal to this. This is putting this minus gmm r plus half m square is equal to 0 and 0. This is 0. This comes that side. So half m square is equal to gmm upon r. Gmm upon r. So minimum velocity, escape velocity will be under root 2 capital G m mass of earth upon r. Now we know the multiplying radius on up and down, r and r. This will be r square. This is r. This is, we know, this is a g, gravity of earth. So we can put simply escape velocity is equal to 2g gravity and radius of earth r. So escape velocity simply we know 2g gravity r under root. This is the simple and easiest derivation of escape velocity and potential energy on earth. Thank you बच्चों. Kindly comment and like and share this video to your colleagues.